Hi everyone, we are moving on to transformations in chapter 3. So here is your first video for transformations. Let's just talk about what a transformation is. All it is a change. So in geometry we change the position or the size of a shape. So we can do all sorts of different changes. The easiest way to remember this, in my opinion, it's just a notation thing, is transformers. So we have Optimus, who turns into Optimus Prime, right? So as a truck, he's Optimus, and then he transforms into Optimus Prime. He changes. The reason I use this example is because for the pre-image, we can just call that O or A or B or C or whatever. And then the image is O prime. So that's why I use Optimus Prime. This little dash here means prime. The pre-image is where you start. The image is where you end. So what you were and then what you became. So pre-image to image. And again, O and O prime. So that prime shows that it's the new object or the new point. Okay, so transformations as a function. You can see transformations like this where they just give you a rule. So they're telling you what they want you to do. So in this case, they're stating that they would like you to add 3 to your x value and subtract 6 from your y value. So if we were to just set up a little chart here, remember, in pre-image, image, so t prime. So if I were given a point for t, like 2, 3, I would apply the transformation that I was told. So I just substitute the x value in for x, the y value in for y, and out pops my image. So again, if I were to substitute my x and my y in, out pops the image. It's that easy. Another example. So this time they're kind of flipping things around. Again, we're just applying the rules. So here is my pre-image, here is my image, and this is what they would like me to change it. So if I had 2, 3 again, now notice it says 2y, so I'm going to multiply 2 times 3 because that was my y value, and I'm going to do x, which was 2 minus 3. So I'm just substituting the values in where it says 2 and applying it. Okay, -8, -2, so again, 2 times y would be 2 times -2, x minus 3, -8 minus 3. I'm just substituting the values in. So that's the most basic transformation that you'll see, where they just tell you a rule and they want you to follow. Here are the transformations that we need to know by name. There's translation, dilation, reflection, and rotation. Let's talk about what each of those means. So a translation is moving a shape without rotating or flipping it. So it's essentially sliding it. So if I had this triangle and I slid it on this slide, that's a translation. It's all staying the exact same, I'm just moving it. So I'm moving it left, right, up, down, etc., etc. I'm moving it. On a graph, this is what it would look like. So here is my pre-image, here is my image, and it is, see, perfect, okay. And again, I knew that because of the primes. So A, B, C, D without the primes is the pre-image, A prime, B prime, C prime, D prime is the image. And this slid 7 units to the left and 3 units down. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, it slid. A dilation changes the size of an object by a given scale factor. We're actually going to do a completely separate unit about dilations. I just wanted to make sure I included it in this first example of transformations because it does count as a transformation. And think about your eye. It dilates, right? It gets bigger or smaller. That's what a dilation is. So something is getting bigger or smaller. It is the only transformation that changes the size of an object. Okay. So as you can see, we have our pre-image in pink and our image in blue. And again, I knew that because of the letters. And in this case, it got bigger, right? The pink got to the blue, so it got bigger. And if we look at the letters, it got bigger, or excuse me, if we look at the numbers, -2 went to -4, 1 went to 2, 2 went to 4. It got bigger by 2, so it doubled. A reflection has the same shape and size, but it's flipped. A reflection is what a reflection is, right? Think about a reflection on water. This is the line of reflection right here. And you see the exact same thing, but flipped. It just, this is down here, this is over here. Everything got flipped. Okay. Graphically, it's going to look like this. So we have our pre-image and our image again. Okay. So A went from -2, 1 to -2, -1. It flipped, it reflected over the x-axis. So it flipped. Like if I folded it, it flipped right over that axis. A rotation turns something. You do this all the time with your phone. When you want to switch your picture, you rotate your phone. That's what a turn is, okay? In geometry, we always rotate to the left. Always to the left, just like Beyonce, to the left, same thing, always to the left. So we rotate to the left. So we have a 90-degree rotation about point P here. So A goes this way, C goes this way, B goes this way. And again, pre-image and image based on the letters. Let's talk about some new vocabulary. Invariant means doesn't change. So in the picture of this reflection, many points change. All of these points go down here, but there's one point that doesn't change, and it's right here. So with a reflection, anything that's actually on the line of reflection, on that fold, it remains invariant. It doesn't change. So invariant means doesn't change. I said that like 7 times, I know. But that's what it means. So it means things that when you transform something, stay right where they are. Isometry. So an isometry means the size and the shape stay the same. So for instance, a reflection and a translation, the size and the shape are still the same. Nothing, I'm still 3, 4, 5, 3, 4, 5. It's still a triangle in both cases, etc. A rotation is also an isometry. Okay. Now there's something called a direct isometry and an opposite isometry. So a direct isometry is going to also preserve orientation. Okay. And what that means is the order of the letters. Okay. So if you think about it like this, a transformation that preserves distance, shape, so same thing as isometry, and orientation. If you can look, I'm going A, B, C, but I'm going A, B, C in the other direction here. So the order changed. What you need to know is that the only thing that is not a direct isometry is a reflection. So if I were to ask you what isn't an isometry, which is just same size and shape, that would be a dilation, because a dilation changes the size. If I were to ask you what isn't a direct isometry, the answer is always reflection, because the order of the letters changes, the orientation, the order of the letters. So again, translation, rotation are direct isometries. Reflection is an opposite isometry. All right, symmetry. You should know what symmetry is, right? It's the butterfly. It's what we all learned back in elementary school. Symmetry essentially means a line that you can create that it would fold over. So, a square is going to have all sorts. It's going to have 4 because you can fold it diagonally and it's going to fall on itself, etc., etc. Any regular shape, meaning a shape with all congruent sides and angles, is going to have the same amount of line symmetry as it has sides. So what I mean by that is this hexagon has 6 sides. It's a regular hexagon because all the sides are equal. It's also going to have 6 lines of symmetry. The rectangle doesn't have 4 lines of symmetry because it's not a regular shape. It doesn't have 4 equal sides, whereas a square does have 4 lines of symmetry because it has 4 equal sides. All right, now let's talk about point symmetry, which is also known as rotational symmetry. The best way for me to explain this to you is think about fan blades turning, okay? When I rotate those fan blades a specific degree, it's going to look the exact same way it did, a second ago. So if we think about this triangle, I can rotate it, I can rotate it, I can rotate it. Oh, look, it looks the same, right? Okay, so I can rotate that a certain amount of times, and each time when this point makes it up here, it looks like the exact same thing it did way back there. That's what rotational symmetry is. And okay, so with a triangle, it has 3 sides or 3 vertices. That's kind of like a distinguishing feature. I call them distinguishing features. It's really called the order. What it means is how many ways you can turn it so that it looks the same. So again, if you think about that fan blade, it has 1, 2, 3, 4, 5, 6 blades. Okay. We always rotate around a circle, which is 360 degrees, and we divide that by 6, so you get 60. So this would be 60-degree rotational symmetry. The order would be 6. The degree would be 60, because again, we do 360 divided by the order in order to get the 60. It makes more sense when you would start to do it, but the fan blades are the best example that I can give you. So that's the basics of transformations. I hope you enjoyed. Have a great day, and I'll see you in class.